All right, so let's look at the 4-2 examples, number 15. Not the homework number 15, but there's homework problems like this. So we got to do all this inverse trig stuff. And the key to the inverse trig is remembering the values that you can get in the range. So what can it spit out, right? So what we reviewed briefly in class was that if it's sine inverse, you're going to get an answer that's in one of these two quadrants. So sine inverse is over here. If it's cosine inverse, it's going to be up above, and one of these two quadrants is going to be the angle that you're going to get. So this is cosine inverse. If it's tan inverse, you're back over here again, tan inverse. If it's secant inverse, secant's like cosine, so that goes over here. If it's cosecant, cosecant's like sine, so it's over here. And then to even things out, we need to put cotangent somewhere, and cotangent happens to be over here. So, so now we can figure out which angles we're going to end up with as our answers. So cosine inverse for part A, where it says cos inverse of 1, well, then we're trying to find the angle that gives us a cosine of 1. So this is the same thing. Like if I call this x, that's the same thing as saying when is cosine x equal to 1? Well, in the unit circle, that happens right here when x is 0. And that's in my range right here, so x equals 0 degrees would be correct. So this would be 0 degrees, or 0 radians. Okay, for part B, tan inverse of -1. So tan inverse, it's got to be first or fourth quadrant. And since it's the slope of the radius, it's going to have to be down here in quadrant 4. So it's rise over run, or y over x, so -1 here over 1 there. And that means that this angle right here is going to be 45 degrees, which is the same thing as saying that I'm at 7 pi over 4 radians right there. Oh, actually, it's got to be between -pi over 2 and pi over 2. That's right. Not 0 and 2 pi. So this is really -pi over 4 right here. That's the answer that the calculator would spit out. -pi over 4 or -45 degrees. Okay. C, sine inverse of -1 over root 2. So that's going to have to be in the fourth quadrant in this case, not the third, even though sine's negative here. So sine inverse of -1 over 2, that's going to be the same thing as y over r. So let's see. We can go down 1. And it's over root 2, which would force this to be 1 here. So this is also a 45-degree angle, which puts it at the same exact place as the one before it. So this one's going to be -pi over 4 also. Let's see, D, we've got cos inverse of -root 3 over 2. And cosine inverse will give you answers between 0 and pi, or 0 and 180 up in the top half. So right here, since it's a negative cosine, we're limited to quadrant 2. It's not going to be quadrant 3 because that never counts really. So whoops, sorry about that. So -root 3, it's the x over the r, so this is root 3 and this is 2. So this is 1, it's a 30, 60, 90, where this is 30 degrees, which means all the rest of it is 150 degrees. So it's going to be 150 degrees or 5 pi over 6 radians. Let's see, E is tan inverse of cos pi. And so that's tan inverse of -1. And so tan inverse of -1, well, tan inverse is going to have to be in this quadrant or this quadrant. And -1, we get a slope of -1 only down here, and that's at 45 degrees away from the axis. So that, again, is going to be -45 degrees or -pi over 4. And then we got one other one, it's F. So let me memorize that. Sine of tan inverse of root 3. Sine of tan inverse of root 3. Sorry my writing's so messy. I'm writing vertically here. It's instead of... I'm not writing in a convenient way. So let's see. Tan inverse of root 3. So that's the rise over the run. So it's like root 3 over 1. And it's got to be in the first or fourth quadrant because of the domain of tan. It's going to be between negative pi over 2 and pi over 2. So if I draw this in, my rise is root 3, my run is 1, so this is a 1, root 3, 2 triangle, which makes this 60 degrees. So then I need the sine of that. So the sine of this is going to be the y over the r. So this is going to be root 3 over 2. Yeah, and that's it. That's it. Then you're done. Okay, I hope this helps.